All right, in this example, we'll find the center of mass of a lamina that is created when we take x cubed and we bound it by the x-axis and the limits of integration 0 and 2. So the first thing we want to do is find the area of this lamina, which will be the integral from 0 to 2 of x cubed dx, which is x to the 4th over 4 from 0 to 2, so 16 over 4, which is 4. So now let's move on to find x bar, which will be 1 over the area times the integral of x times f of x, so x times x cubed. So that's 1/4, and then x to the 4th here will integrate to x to the 5th over 5 from 0 to 2, which gives us 1/4 times 32 over 5. So that's 32 over 20. Which is going to narrow down to 8/5. So that is my x bar. So now let's look for y bar. Y bar will similarly have 1/4 out in front and then the integral from 0 to 2, but then it's just going to have f of x, which is x cubed, all squared, dx. So x cubed squared is x to the 6th. Oh, sorry, forgot the 1/2. 1/2 f of x all squared. So this then, let me pull out the 1/2 first. So I have 1/8 out in front, and then I have x to the 6th, which integrates to x to the 7th over 7 from 0 to 2. So 7 times 8 is 56 in my denominator, and x to the 7th is 128. And this simplifies to 16 over 7. So my center of mass of this lamina is 8/5, 16 over 7. All right, and I just have one last example to show. It's on the last page, example 4, and they want me to find the center of mass of the first quadrant region bounded by x squared and y to the 4th. So a quick sketch here shows us, y equals 4. That's here, and that's here. So this is my region. And the reason why this is a special problem or a different problem that we need to address is because we're doing the area between two curves, not just underneath a single curve. So you'll notice that my x bar becomes not just x f of x, but x times the difference between the two functions, f minus g, top minus bottom, by the way, same as always. And then for my y bar, I need f of x squared minus g of x squared. So it'll be top squared minus bottom squared. So I can start once again by finding the area of my region. So I need top minus bottom, so 4 minus x squared dx, and I need to know this point of intersection, which looks like it's the point 2, 4, if I just set the curves equal to each other. So I'm integrating from 0 to 2. So when I do that, I get 4x minus x cubed over 3 from 0 to 2, which is 8 minus 8/3, which is 16 over 3. So that is my area. Let's go ahead now and get x bar, which I start with 1 over area. And instead of taking 1 over 16/3, I'll just take 3/16. And then I need the integral from 0 to 2 of x times, and then I need top curve minus bottom curve, so 4 minus x squared. So then I will go ahead and integrate. When I distribute here, I get 4x, so that integrates to, let's see, 4x squared over 2. And then x times x squared is x cubed, so that will integrate to x to the 4th over 4. And that's from 0 to 2. And so I have 3/16 times, and then when I multiply this all out, I'm going to have 8 minus 4 in there. So 4 times 3/16 is 12/16 or 3/4. That is my x bar. So now let's find y bar. Once again, instead of doing 1 over area, instead of doing 1 over 16/3, I'll just do 3/16. And then I have from 0 to 2, and I have 1/2 times, I need 4 squared, which is my top curve, so 16, minus 4 minus x squared, my bottom curve. I'm sorry. That is not my bottom curve. My bottom curve is just x squared. So I just need 4 squared minus x squared squared. So that's x to the 4th dx. So now, if I kind of clean this up, pull out the 1/2 out in front, I get 3 seconds. Then when I integrate, 16 goes to 16x, x to the 4th goes to x to the 5th over 5, and then I'm going from 0 to 2. So then I have 3 seconds, and then 16 times 2 is 32, minus 2 to the 5th is 32 over 5. And when all is said and done and I simplify this, I get 12/5, which leaves me with my center of mass for this lamina as the point 3/4, comma, 12/5, which are my x bar and y bar.